Greetings of the day to all. I am Shikha Kansal and we will be talking about rank correlation. Although we have already done rank correlation, but in that PPT we were talking about rank correlation method when ranks are given to you. But here we will be talking about when the ranks are not given and when the ranks given to 2 different or 3 different observation is same, how to proceed for those type of problems. So, moving ahead, we have already discussed the Spearman's rank correlation coefficient. The formula is R is equal to 1 minus 6 summation of d square whole over n cube minus n, where d is the difference between the ranks given to different observations of different variables. So, the first case we have already discussed in the earlier PPTs, but here in this PPT we will be discussing, as I have told you, when the actual ranks are not given to us. So, what happens is, when the actual ranks are not given to us. So, when we are not given the actual ranks, the question is in the problem is in the actual data form. So, it is very necessary to assign the ranks to the different observations of the different variables. The ranks can be assigned by taking either the highest value as 1 or the lowest value as 1. What does this mean? That this mean, for example, if I want to give 10 marks to someone who is extra intelligent and 1 marks to someone who is less intelligent, that means I am giving highest value as 1 or highest value as 10 to somebody or lowest value to that somebody, but that procedure should be same in both the series or both the variables. For example, if there are variable x and y and the observation for them in terms of most intelligent, moderate intelligent, least intelligent and poor. For example, if we take the case, and there are 4 cases in this. So, I am just supposed to assign either 1, 2, 3 or 4. So, how to give them ranks? For me, for example, I am giving to poor if the rank which I am giving to poor is 1 for variable x. So, for variable y also I am supposed to follow the same rule. We cannot change the rule for different series of the same problem. So, we are supposed to assign the same rank for both, for the question, for the problem which involves different variables. For the most intelligent, for example, I am giving 4, for the moderate one I am giving 3 and for the least one I am giving 2. So, this is the procedure which I am following, but I am supposed to follow the same procedure when we are talking about different series of which are involved in the question of the same equation. So, we are supposed to, that is what we have written, but whether we start with the lowest value or the highest value, we must follow the same method of ranking in both the in the question for both the variables. So, for example, we have a question here in which the index number of security price of a certain joint stock company is given below to you. Using rank correlation method, we are supposed to find out the relationship between the debenture price and the share price. Now, here the debenture price is given to you and the share price is given to you. No rank is given to you. You are supposed to just find out rank, or you are supposed to rank these debenture price and the share price according to your own wish, but that wish has to be same for debenture price also and the share price also. For example, if I am giving my rank 1 and rank 2 here, for example, for in rank 1 here, when I am giving rank 1, for the highest value I am giving 1. For the highest value, that means I think to the lowest value, sorry, if I am giving to the lowest value, I am giving 96.7 as my rank 1 in debenture price, and we can call it as x, we can call it as y. So, rank becomes rank x and rank y. the lowest price debenture price was 96.7. So, I am giving it as rank 1. Moving ahead, 96.7, what is the next rank higher to 96.7 is 97.1. So, I am giving it as rank 2. 97.8 is rank 3. 98.3 is rank 4. 98.4 is rank 5. Then 99.2 is rank 6 and 98.8 is rank 7. So, this is one method of ranking. When I have given when the price was least, I have given rank 1. In the same manner, I am supposed to follow the same rule when we are talking about share price. Here also we are supposed to give rank 1 to the least price. Thus, what is the least price here is we will find out. The least price is 73.1. So, I will give it as rank 1. Moving ahead, after 73 it is 75.8, it is rank 2. Then 75 it is 77.2, rank 3. Then after 77 it is 78.9, rank 4. After 78 it is 83, rank 5. Then 85.8, rank 6 and 87.2, rank 7. So, this is how we are supposed to give ranks when ranks are not given, but follow the same procedure for both the debenture price and the share price, that means both the variables which are given in the question. So, this was, as I have told you, debenture price, and this was share price, debenture price, and this was share price. This was rank which was given, which we have just found in the question, that is 3674. In the same manner, 3674. This was the rank which was given, which we have found out, rank x and rank y. The question demands for summation of d square, that is r x minus r y. When we were talking about case 1 in the earlier PPT, we were talking about r 1 minus r 2, same as r x minus r 1 r y. Here we have taken the series as x and y, there we were taking the series as 1 and 2. So, here r x minus r y, r x minus r y, if I find out d here, r x minus r y gives me 3 minus 1 gives me 2, 7 minus 6 gives me 1, 6 minus 4 gives me 2, 4 minus 2 gives me 2, 5 minus 3 gives me 2, 1 minus 7 gives me minus 6, 2 minus 5 gives me minus 3. But my question demands some d square, that is the difference square. That means, I am supposed to square all these differences which are obtained here. 2 into 2 gives me 4, 1 into 1 gives me 1, 2 into 2 gives me 4 again 4, again 4, minus 6 into minus 6 gives me 36, whereas 3 into 3 gives me 9. The question is demanding for summation, that means, I am supposed to add all the differences together, all the differences of squares together, it gives me 62 here. Putting this 62 into the answer in the formula above, and we are also supposed to find out what is n. So, n is number of observations, that means 1, 2, 3, 4, 5, 6, 7. So, n is equal to 7 here. So, putting n is equal to 7, I have 7 raised to the power 3 minus 7. So, 6 summation d square gives me 6 into 62 divided by 7 raised to the power 3 minus 7, which gives me 1 minus 1.107 is equal to minus 0.107. This minus shows a negative correlation between the debenture price and the share price, but there is a relationship. What relationship they have is, it can be stated that there is a negative correlation between the debenture price and the share price of a certain joint stock company, but there is a relationship. This was one kind of question which we have discussed, but moving further, when the ranks are equal, that will be discussed. In the case 3, when the actual ranks are equal, what we are supposed to find out? In some cases, it is found necessary to assign equal ranks or two or more individuals or entries. In such cases, it is compulsory to give each entry or each individual an average rank. What is that average rank means? Thus, if two individuals or the entries suppose have at the 5th place, they have equal rank. For example, for the two entries we have given 5th, their equal ranks are given at the 5th place. So, what we will do? We will add these two, that means 5th place rank and 6th place are the equal. So, what I will do? I will add 5 plus 6, but since there are two observations which have equal ranks, I will divide it by 2, and to both the observations I will give the rank 5.5. Now, this is the case when we have two observations with equal ranks, but if there are 3 ranks with equal observations, we will just add them, we will just give. So, for example, suppose if they are at the 5th place again. So, what I have 3 observations at 5th place having equal rank. So, I will add 5 plus 6 plus 7, but they will be divided by 3 because there are 3 observations with equal rank. So, I will give 6 value, 6 number or 6 rank to all the 3 observations, and to the next observation after 7 we will give it as 8, we cannot give it as 7. Here also in this case when the 2 observation had the equal ranks, we will give the next observation as 7 and not 6. In the same manner, we will just escape those ranks which already has given, and we have given a common rank as 6 here. Therefore, where 2 or more individuals are to be ranked equal, the rank assigned for the purpose of calculating coefficient of correlation is the average of ranks which these individuals would have got had they been differently slightly from each other. So, when there are 2 or more observations with the equal rank, we are supposed to just add them, add not the observation, but we are supposed to add the ranks of these and give them the same rank as the average, and to the next observation we are supposed to give the next rank, not the same rank. For example, look at the question we have. For example, we have a small change in the formula as well for these kind of questions. What is the change? We are just supposed to add 1 over 12 m cube minus m to the value summation of d square. The earlier formula had r is equal to 1 minus summation of d square whole over n cube minus n, but here what we have added? We have added this value here to d, that means we have added this value here. So, this is a small slight change when we are talking about when we have equal ranks. So, what is m here? M is how many observation had equal ranks is m. M stands for number of items whose ranks are common, whose ranks is common, whose ranks are for whose places we are supposed to obtain the average. For example, M1 could be 1, 2, 3 stands for the number of items an observation is repeated in the data set for both the variables is n, is m. We will discuss it in the question further. Note, if there is no more than one such group of the items with common ranks, this value is added as many times as the number of such groups. Therefore, the formula becomes r is equal to 1, 6 summation of d square, and we have opened up a bracket here because there could be many m's added. It is not that only 2 observations, only 3 observations are having equal ranks. There could be more than 2 observations which are placed at the same rank, and there could be one more lot which is placed at the same rank. So, there are different lots, different observations with the same rank. Could be 2 observations with the same rank, this is one lot, could be another lot with the same ranks. So, that is another lot. So, what happens is here 1 over 12, this will be repeated as many times the ranks are repeating. So, this is one lot which is having the same rank, but what if there is another lot also? So, we will repeat this addition here. As the number of lots increases, as the number of lots with the same rank increases, we will keep on repeating it as many as that n number of times, divided by n cube minus n. Just see the question. For example, an examination of 8 applicants for a clerical post was conducted, but it was taken by a firm. from the ranks obtained by the applicants in an accounts and statistics paper, compute rank coefficient of correlation. So, we have obtained the applicants A, B, C, D, E, F, G, that means 1, 2, 3, 4, 5, 6, 7, 8. So, my n becomes 8. Now, these are the marks of accounts which are given to us 15, 20, 28, 12, 40, 60, 20, 80, and marks in statistics is equal to 40, 30, 50, 30, 20, 10, 30, 60. Now, what we are supposed to do is, we are supposed to find out the rank coefficient correlation. How? We are supposed to find out ranks first. Now, these were the applicants, equal to 8, equal to 8, equal to 8 here. So, marks in accountancy as computed as x variable and they are given y variable, x and y, 15, 20, 28 as already given, I have just copied it here, marks in stats just copied it here. Now, what happens is R1 and R2 I am supposed to already given, this is something which I am supposed to compute. How I am supposed to compute is, I have already told you that when the ranks are not given, we are supposed to give the ranks, but my procedure, my giving of the way I am giving ranks to my observations or my series of x should be same for series of y as well. So, the least marks has got rank 1, whereas the highest marks got rank 8. So, why only 8? Because n is 8. So, I have given rank 1 to 12, rank 1 to observation of D, because D has obtained the least marks in accounts. So, I have given 1. After 12, I have 15 as rank for 215 to A, I have given 2 rank, but applicant C, but applicant B and applicant G, they both have the same marks in accounts. So, what we are supposed to do is, in order to calculate ranks for B and G, what I have done is, I have added the rank for B, I have added the that means, what rank I was supposed to give them? I was supposed to give them rank 3 and rank 4. So, I have added the rank of these C and G together and I have obtained the aggregate of these. I have not added the marks together, I have added the rank because we are finding out the rank. So, what we are doing here is, because because B and G have obtained same marks in accounts. So, same rank has to be given to them. We cannot give same ranks, we are supposed to obtain the aggregate of that rank. So, what is the aggregate here is, the third rank is and the fourth rank aggregate. So, I am supposed to do is 3 plus 4 divide by 2, which gives me 3.5. So, what rank I am supposed to give to B and what rank I am supposed to give to G is 3.5. Now, I am not supposed to give fourth rank, because fourth rank I have already used here. I am supposed to go to fifth rank now. Fifth rank is given to the higher marks, the person who has obtained higher marks. That means, I will give fifth rank to C, then sixth rank to E, because he has obtained, because E has obtained 40 marks. Then moving ahead, the person who has obtained higher than 40 is the F, that is 7th rank, and then moving ahead, H has got the 8th rank, that has he has obtained 80 marks. This is one kind of ranking, this is one part of ranking when we are talking about marks of accounts, but when we talk about marks of stats, there is another ranking method which will give you another idea as to how to rank. This portion of ranking, here what we are supposed to do is, the least marks, as we have followed the procedure of giving least marks as 1. So, in the same manner, we will give in the marks marks of stats also, we will give least marks as rank 1. So, when we are talking about marks of stats, here also the least marks is 10, I have given rank 1 here. The next higher rank, in the next higher marks is 20. So, where it is 20 to E, I have given rank 2. Now, after 20, the highest marks, the higher marks after 20 is 30, 30, 30. So, there are 3 places at which 30 is being repeated. So, what I am supposed to I am supposed to find out, I am supposed to find out after 2, I am supposed to find out third rank, I am supposed to find out fourth rank, and I am supposed to find out fifth rank divided by 3. Why I am doing it? Because there are 3 places, there are 3 people, there are 3 applicants who have got the same marks and to whom I am supposed to give the same rank. So, what I have done is I have added their rank positions, that is third, fourth and fifth, and these third, fourth and fifth we are not supposed to give to anybody else, but what I am supposed to do is I am supposed to get the average of 3, 4 and 5 divided by 3, because there are 3 in number. So, I have got here is 4. Fine. So, I have given 4, I have given 4 and I have given 4. After 4 comes 5, but I cannot give 5 because 5 is already being added with the this rank. Now, moving ahead, I am supposed to give rank 6 to someone, some applicant. So, 6 rank after 30 is becomes 40. Applicant A has obtained 40 and rank 6 will be given to applicant 40. There is no applicant A, there is no fifth rank, there is no third rank, but third, fourth and fifth rank has been clubbed together and fourth rank has given to 3 people. So, this is rank 6, applicant C 50 marks got 7th rank and applicant H has got 8th rank. So, this is how we are supposed to rank the applicants when they have equal marks obtained or when the equal ranks are given to you. Now, my question demands for D square. What I am supposed to do is I have D, I have ranks with me. So, what I will do, I will find out R1 minus R2, R1 minus R2. So, 2 minus 6 gives me minus 4, 3.5 minus 4 gives me 0.5, 5 minus 7 gives me minus 2, 1 minus 4 gives me minus 3, 6 minus 4 gives me 6 minus 2 gives me 4, 7 minus 1 gives me 6, 3.5 minus 4 gives me 0.5 and 8 minus 8 gives me 0. This is one difference which I am supposed to find out D between the rank 1 and rank 2 by the applicants A, B, C, D in accounts marks, that is X, and statistics marks, that is Y. But my formula demands D square. So, I am supposed to just square all the differences which we have just obtained, that is minus 4 into minus 4 gives me 16, 0.5 into 0.5 multiplied twice because it is square, it gives me 0.25, minus 2 into minus 2 gives me 4, minus 3 into minus 3 gives me 9, 4 into 4 gives me 16, whereas 6 into 6 gives me 36, 0.5 into 0.5 again gives me 0.25 and 0 into 0 gives me 0. My formula demands for summation D square. So, I am supposed to add all these values of D square and I will obtain here 81.5. How to put this in the formula and how to use this? Now, the formula is this, a big formula here, 1 minus 6 we have already obtained this is okay. What is M1, what is M2? This is the thing which we are supposed to find out. M1 is the number, the rank, the number of people with the same rank is M. That means, here is item 20 which is repeating itself 2 times, whereas here is item 30 which is repeating itself 3 times. So, it is repeating twice, 20 is repeating twice and 30 is repeating 3 times. So, as 20 is repeating 2 times in series X and Y is repeating in series Y, 30 is repeating itself 3 times. So, M1 here becomes 2 and M2 becomes 3 because they are repeating 2 times and 3 times. Now, we are not writing the number which is repeating itself, but we are writing down how many times it is repeating. So, moving further in the formula, R is equal to 1 minus D we already knew, the D was 81.5, so putting the value into the formula is equal to 81.5 plus 1 over 12, m 1 as I have told you is 2 raised to the power 3 as demanded in the question in the formula, minus 2 plus 1 over 12 was already given, m 2 is 3 I told you, because 30 is repeating 3 times in series y. So, I will write down m 2 is equal to 3. In the same manner, we could have other variables as well, sorry, other observations, or we can say other numbers as well which could repeat themselves n number of times. So, we will use them as well, we can use them here, we can just add them here and we can use them here. So, putting in the formula we have just put all the values here I have told you. So, r is equal to 6 into 81.5 plus 0.5 plus 2 divided by 504, this will give you r is equal to 0. What does that mean? If r is equal to 0, what does that mean? It means there is no correlation between the two variables. It means there is no correlation between the variables of marks x, that is accounts, and variable y, that is statistics. That means we can quote that a person who is good in stats does not mean that he could be good in accounts as well, and a person who is good in accounts cannot be quoted he is good in stats as well. Therefore, we can see the result here. The result shows there is no correlation between the two. This shows there is no correlation between the marks of the two subjects. Therefore, we cannot say that a person who is extra brilliant, extra intelligent in maths could be good in other subjects as well, or here as we have seen a person who is good in accounts can be very good in stats as well. Two different things, two different factors and two different intelligent level of a person. Now, what are the merits of rank method? This method is easy to understand and its application is simpler than Carl Pearson's method. This method is useful for correlation analysis when variables are expressed in qualitative terms. The method is developed to measure the statistical association or relationship between the two variables, say x, y, or we can say a or b, when only ordinals, that means ranks, are given to us. And we can also convert the quality of a person into rank by giving them ranks. We can compute a quantity answer. So, what are the limitations along with the merits we have? The values of both the variables are assumed to be normally distributed and describing a linear relationship rather than a non-linear relationship first. A large computational time is required when the pair of values of the different variables exceed 30. As I have told you, if the number of variables exceed 30, it is very difficult to give ranks and to compute ranks. So, it is better when we are talking about a rank correlation method, we should use the data which with the observations less than 25 or less than 30, because if the observation exceed 30, it becomes a huge data. It is very tedious and the computation time it exceeds. And the third limitation, as we can see, this method cannot be applied on grouped data. This cannot be applied on group data to measure the association between the two variables. Grouped means we cannot have more than 2 or more than 2 series. So, grouped means we cannot apply this data to mass. We can only apply to the small group. That's all from my side. Thank you so much.